so that you are better prepared for that. So that is that is the start of your assignment like last time. So at the start of your assignment 1, so this is the start of your assignment 2. It's very long, so you just go inside and then take a look at that. It's very long, so we will try to use some time to explain what that is about and some basic understanding in the next lecture. And hopefully you will be able to get to know the lab pretty well before you actually go to the lab. Let's finish the things for today. We are doing something about creating turtles, right? So you remember that creating turtles thing is a group exercise. So we said that, let's just understand how it works with these things and then try to make a version for yourself from scratch. Don't read the example code, make one for yourself. Hopefully you have done that. Try it out and compare with what you have done and see whether this is actually a good idea to make it in a list or anything like that. Okay, so I'm not going to look at that again, but we have another example at the end. So this example, I have not actually mentioned that, but this is just a very simple example. Is this example related to your creating turtles idea in the discussion here? No, it's not related. Somehow this example is a little bit odd. If you run it, then you will see that it's just something which looks like this. Run this example, there is a little turtle inside the screen, keep on changing the size and then moving around and aimlessly, which is just like that. So look at that. Oh, well, what's the point of this? The point is, we are trying to demonstrate the use of some of the functions that we looked at in one particular slide. That thing we are trying to do is about those about those functions that allows you to get things from the turtle. You can read the position from the turtle, you can read the heading from the turtle, you can also read the X coordinate of the turtle, you can read the Y coordinate of the turtle, and by reading all this information, we try to check the X position or Y position of the turtle, and then if it is necessary, we turn the heading of the turtle by 90 degrees. So that's why it is going around like that. And okay, what's the point? What's the point? So the point is we are using those functions to read the information from the turtle to do some stuff. Okay, so probably you will say that this is kind of meaningless, but well, that's just an example. So we are trying to use some of these to try to demonstrate how to use those. So again, that example has nothing to do with creating a turtle. So you try to look at, hey, where is the turtle? So it's not creating a turtle. And so it's kind of simple, it's just like that. Okay, so forget about this. Then let's look at the next one. So the next one is rather important. This is dictionaries. Oh, well, why is it important? Because this is yet another data structure that we have to learn in the course. What have we done so far? We have learned the variables, we have learned all those like numbers and tags and all those kind of things. And then later on, you know that you can use lists and tuples to store multiple items together. And then later on, you know that string is actually the kind of a family together with lists and tuples, so all of them are collections. It's just strings, a collection of letters and symbols. And well, we are going to add these guys together, dictionary, into the family of lists, tuples, and string. Okay, so when I say list, tuple, and strings, obviously you know that they are for collection of stuff. So it's very obvious that this is also for collection of stuff. Dictionaries. Well, everybody knows dictionaries. Everybody knows that dictionaries looks like these, so this is a dictionary. So how can you use a dictionary? So are you going to find a word by going to a page number when you use the dictionary? You don't do that, right? So if I ask you, hey, what's the meaning of Gibson? And then you won't go and find, oh, page 50. Then I will be able to get Gibson. You don't do this. You are going to find the word and then get the explanation, all right? So how can you find the word? Well, there is some indexing in the dictionary so that you can find the word and then get the explanation. So the thing that we are trying to point out is this dictionary kind of idea is going to be done inside our Python data structure, which happens to call dictionary as well. But it's not exactly the same, because in using a real dictionary, you have some kind of indexing so that you can find the starting letter. So that is the real dictionary. For a programming dictionary that we are doing, it is just like this. Hey, you look at that, hey, what's the meaning? The meaning is similar to a dictionary. You are going to have like in the kind of things that is happening for dictionary, that will be word mapped to the explanation. So word, explanation, word, explanation. If I want to find the meaning of the word, get the word, and then you will be able to get the explanation from the link. Okay, so this is what we call a simple mapping structure. Alright, so why is it a mapping? Because one thing has been mapped to another thing. So that's a mapping structure, or simply speaking, that is just a key pointing to a value. And then there are a lot of these key and value things inside my mapping or the dictionary that we have. Okay, enough of these kind of picture and stuff. And then probably you may say, hey, give me an example, and we will be able to understand the whole thing. This is just a kind of revision. You can access content using lists, tuples, or strings by using numbers, which is just saying, like what I said, if you try to look for the word in the dictionary, do you use a number to do it? You don't do it. So this is what is happening for lists and tuples. And when you use a mapping, you directly use the keys. So in terms of a dictionary, you directly use the word. Okay. And so let's give you an actual example. Hey, what's this example is about? We are saying that using dictionary is sometimes a little bit better than using lists, for example. So this is trying to say that I am going to write a program to explain the color of fruits. So I'm telling you that apple is red, grapes is purple, mango is yellow, orange is orange. Okay, and then you try to put it in the program. If I use a dictionary, this is the natural way of doing it. I am explaining the color of the fruits. So I'm going to give you mappings. Apple mapped to red because apple is red. Grapes mapped to purple is grapes is purple, and then so on and so forth. Okay, so this is the natural way of using this dictionary. And then this is not a natural way of using a list to try and do the same thing. What are we trying to suggest is, if you cannot use a dictionary, which we are suggesting that this is better, the alternative way is you can use two lists. So this is one list and this is another list. The first list store the fruit names. The second list store the fruit colors. And we are trying to match the name with the color by using the same index. Alright, so that is the structure. Probably you can think of a better way, but then this is more or less the only way, more or less the way that you can do with lists. So this is very simple. Do a mapping, map together. This is, you have to put the information together separately. You can link them together by looking at the index. So if I ask you this two lists, if you are given these two lists, let me ask you a question. So the question is, what is the color of mango? Okay, I'm asking you this. What is the color of mango? If you have to do it using these two lists, what is the procedure that you have to take? So write a program to do it. So just tell me what to do. So I'm asking you what is the color of mango. So what would you have to do?
Search the position of mango in the first list. And then use the position and then input to the second list and find the yellow.
Yeah, that's it. Finish. Very simple. So you have to get the two lists working together. Why? Because the two lists are not related. Well, theoretically inside a program, if you say, when I write the program, they are related, but they are not related. So you need to go through the first list, find mango, get the index. So you know how to do it because there is a way to do it using a list. But after you get the number does not carry any meaning. But you know, okay, the number can get me the correct color. So you use the number, you use the index, go to the second list and get back that particular color out. So you have to do a few steps to try and do this mapping by yourself. If you use dictionary, no need to do it directly. You ask, hey, what's the color of mango? Just ask, and then you get color yellow out of this. And so you look at that, well, you just say it like this, but how does it work? It's very simple. We can just try to write it out, and then you kind of understand it. Certainly, you already have the same kind of thing inside. So you have the same kind of thing inside that example, but let's try to build some simple example as well. So let me just create a dictionary guide over here, and it's just these, delete the whole thing. Okay, so in order to make a dictionary, it's really simple. You just do this, give it a name, let's say fruits. I'm going to use the same example, when you put together things inside dictionary, you are going to use the brace. So brace, okay, not the square brackets or the parentheses. You use brace. So open brace, close brace. So this means that I'm doing dictionary. Okay, so once you are inside here, you already get the idea. Oh, you know, whenever I do stuff inside Python, multiple things I put commas in, right? Commas. So there are a lot of commas to separate the things. Alright, so what are the things inside? So let me just write it for the first one. So apple is red. Okay, so I'm just giving you apple. So apple is the key. And then followed by the colon. So this colon is not the usual colon that you use when you write your program. So you understand that whenever I type colon, meaning that going over the next line, I have to go inside because whatever comes after the colon is inside the line that I'm writing. Okay, so that's the colon. This colon is not that colon. So this colon means the length together of this thing. So this colon really means the line over there. So the colon is really talking about this. So I am linking apple and red together. So apple is the key, red is the value. Okay? So then, that is one item. Oh, there are two things, right? I know there are two things, but whenever you use a dictionary, this item is the mapping of the key and the value. So it's always like that. Using a dictionary is a pair. It's a pair for one item. So this is one item, comma, another item. So that will be like, let's use the same kind of example. Grape is purple, and then, let's see. So mango is yellow, and all those kind of like things, exactly the same as the notes. So orange is orange. So that's how you build this simple dictionary. Okay? I have a dictionary so that I'm going to map apple to red, grape to purple, mango to yellow, orange to orange. And so, question number 2. This is a collection of things. If you use lists and tuples in order to get back items, you try to use the name of the list and then enclose it using the square bracket. And by doing that, you can try and find the item inside. So here, I can do exactly the same thing. This is the dictionary. I use square brackets again. Well, by the way, just like tuple, you use parentheses to enclose the items. But when you try to get back the item, you are also going to use square brackets. So dictionary is the same. You use the braces to enclose the item. When you want to get it back, you use square brackets. So square brackets is the way you get back the thing. If you want to get back the thing, you don't put numbers. No more numbers. What you do is, you are going to put the key into here. So let's say I put mango here, and then if I print it out, what do I get? I would get the color of mango directly yellow. So that's the output. Okay? So this is like yellow is the things that I'm going to get if I just print the color of mango like this. Alright, so after you read this, probably you have a kind of a good idea what's happening in the dictionary. So similarly, I want to know the color of apple. So you just change your key that you are asking to be apple, and then if you run it, then you get the color of apple is red. Alright, so no more numbers. So don't use numbers. So it's just always the key. Give me the key, I give you the value. Give me the key, I give you the value. Okay, so what's next? You can try to see what kind of things that you can do for a dictionary compared to a list and a tuple. So you know that lists and tuples are very different. So they are still collection of stuff, but list very flexible. Tuple is not flexible. And we already explained that string is more kind of close relative to tuple than list, because string and tuples are kind of not very flexible. So how about dictionary? Dictionary is closer to list. So dictionary is very flexible in the sense that you can change the thing anytime you like. For example, I can do this. So let's say my mango is kind of straight. So I can try and say that my mango, okay, I'm trying to get back mango, but I'm going to replace the value from yellow to green. Okay, strange kind of mango or kind of raw mango. And if I do this, you will be able to show that the color of mango is green. You are changing it. Okay, and well, maybe you say, you are doing this, maybe you will have two mangoes inside the fruit. So one mango is yellow, another mango is green inside here. But one thing that you have to be sure is that because I'm using the key to ask for the value, so the key here are unique values. So they are all unique. You cannot really duplicate the keys. So that's the same as a list. When you use a list, you are using the number, the index. The index is going to give you back one thing. You can only have the same index pointing to two things. Okay, so the key is kind of unique. One key mapped to one value, but not the other way around. So you can have multiple things as the values being mapped with different keys. So like if I have a mango, I have a really strange mango. So the strange mango is red. Okay, so like that. There are actually red mangoes, so no problem. So here is red mango. So I have red apple, I have red mango, I have multiple values that are mapped together with a different key. So no problem. Alright, now change is no problem. Add. So how can I add? Add is no problem. I just do this strawberry guy. So let's say you are red again. So then I can easily add this strawberry guy, and then you will know that I have a strawberry of red like this. Or alternatively, if you want to see the whole thing, you just do this, print out the fruits, and then you will be able to see the whole content of the dictionary, and then you know that I have red apple, purple grapes, yellow mango, orange, and red strawberries, like that. Okay, and this is adding, so you can change, you can add, delete. So delete is rather strange. So how is it strange? You have to use the word delete, D-E-L, short form, delete. Delete grapes. I don't like grapes. Delete grapes, but don't write it like this. You have to delete the grapes inside the fruits. So delete the grapes inside the fruits dictionary. Okay, I am adding a strawberry, and then I'm deleting grapes. Okay, do this, run, and then you get a new version of the dictionary. So apple is red, mango is yellow, orange is orange, strawberry is red. No more grapes. So you can add, you can change, you can delete, which is the same as list, but the way that you do it is entirely different. So entirely different to list. So you don't really use the list idea to do it here, like, oh, fruit dog remove. No, it's not like that. So delete. Okay, so what else? Finally, the final thing is, you can do this printing out the whole dictionary out, but you know that you can also do this in your list idea. The thing is, you can use a for loop on your list and tuples. So how about this? If I use my for loop in the dictionary, what is going to be the content here? So lists and tuples are kind of simple because these are just items separated, but fruits dictionary here is a little bit not the same because you have a pair of things for each item. So if I get back the item, which one is the one that you're talking about? So let's just show it up. Do this. I'm printing you those items that I get from fruits when I'm doing this for loop. You get apple, mango, orange, strawberry. Hey, where are the colors? No colors. So that means if you write it like this in the loop, you are trying to get each key from the dictionary and run the loop. So you are not getting the entire item. So the entire item is key mapped to value. So when I use this for loop, I get each key and do it. Okay, so this is the only strange things that if you read this kind of program, and you may think that this is getting you the entire thing. No, it is only getting you the key. So this is a little bit ambiguous or confusing. Okay, so is there any other things which is not confusing? If you don't want to be confused, no problem. You can just write fruit keys. Then that is obviously giving you back the keys. So that will be really the keys. But even if you don't type dot keys, it will be the same. Alright, so that's why it's a little bit confusing. Okay, how about this? Values. So this is not really confusing. I am getting all the values out. So red, yellow, orange, red. Alright, how about the entire pair of things? I can say items. So I get back all the items, everything, every single thing. Run. You will see that each time you get the pair. The pair will return as a tuple. So apple to red, mango to yellow, orange to orange, strawberry red. Okay, so that means when you use a for loop, you have options. You can do it with just keys, you can do it with just values, you can do it for the entire thing, or if you just delete all this, always you get back the keys. Okay, so, and the other thing is, if you use these items, it is very common that you can write like this, which is the same as what we do in the notes. So you will use two variables to get back your key and value. Key and value, and you will be able to get back both of them together. So I can get the key and the value together in two different variables, show it up like that, and this will save you some time to type the key and value. What do you mean? So for example, if I don't get the items, this is supposed to be just the key. So this is just the key. If I want to preview the values, then you will have to do this. You will have to write this to get the key to retrieve your values, which is going to get you back the same thing. Okay. Now, finally, if I do this values, so if I do this with the value here, and then you may ask, hey, can I use the value that I get from here to get back the key? Well, you can try to think about it. How can you use the value to get back the key? But if you explore a little bit, try to understand what a dictionary is about, this is not possible. So if you try to get the values, you will not be able to get back whatever key that you are talking about. So you can only print out the values. So when you use the keys, no problem. Just get the values. The values is just the value. So not exactly trivial to try and give you back that particular key. Okay, now anything else? No, finished, but there are just some minor stuff. So let's look at the notes to understand the minor stuff. By the way, use a silly example. So silly that I'm just using the fruits. So this is super silly. So we give you a picture, and then we said that our program works with the picture. But in fact, the program does not work with the picture because it's not so advanced. So we are making a program trying to say that where are the heads. Okay. So well, obviously this is me. Okay. And then you look at that. Oh, so you are behind that guy. Who's that guy? This guy is our president. 2 times before, okay? So, 4. Well, that's probably differently. So, then you are having a program to try and point out where are the heads. So, David is there, Gibson is there, Jugesh is there, and then Paul is there. Okay, and this is a dictionary mapping the key, which is the name, to some tuples. Alright, the tuples are values. Nothing really special here. And we are demonstrating that you can ask for the values. So as you know, use the key, get back the value. So this value will be the tuple. And then you can change like this. You can try to use the key, change the value anytime you like. So you can add, if you want to, you can add another head. So with the name, and like this is adding things into your dictionary. If you want to, you can delete, remove things from the dictionary, which is just exactly the things that I'm talking about, but it is messing about with the picture version, which you mentioned. Picture? What picture? So it's nothing really related to the actual picture, but it's just messing about. So this is where we use a very computer science name, traversal. So well, probably, well, why suddenly talk about this? That simply means that going through the thing. Okay, going through the thing. So we use this traversal to talk about going through things. Okay, so this is a very computer science term, but we don't really care about that. So we just tell you that in order to look for everything, use items. If you don't care about everything, you can use keys, or just omit the keys, or the values only. Okay, this is just kind of simple things that we have talked about. So there are a couple of minor things. Let's get back a little bit. If we use this traversal idea, then you can look at each item one by one. Naturally, you will think that the items that you're going to send back to you in the for loop is the ones that you get into the dictionary in that order. What do you mean when you try to use a for loop to get items from a list? You will get the items having the same order as the one that they are stored inside the list, right? If the list is 1, 2, 3, 4, then when you use a for loop, you get back 1, 2, 3, 4, same order. So that means now, well, why do you suddenly talk about that? Because if I use a dictionary, you expect the same thing. If I define the dictionary having like David, Gibson, Jugesh, Paul, the way that you are going to traverse the thing and print them out is David, Gibson, Jugesh, Paul, same. So what are you trying to say? So I'm trying to tell you that don't take this one as always like that. What I mean is, actually, previously, they are not like this. So how previously? Any Python version before 3.6, that means starting from 3.5, 3.4, 3.3, anything before 3.6, it does not work like that. If you put things into a dictionary and you print them out, this may be the one that you got. Oh, obviously the order is not the same as the one that we have added, so the order that you print them out is different from the order that you added the thing. Okay, so you look, that's very strange. How come? Because the dictionary idea is not including order of items. So list, tuple, strange, they have the order already stored together. So order and content are important for those. Dictionary, it is always about the mapping. It is not always about the order. So that before Python 3.6, order is not important. So it's just going to store it in some random order and then print it out. So you never know what is the actual order. So that's the thing that we are trying to point out. Then we may say, hey, who cares? I'm using Python 3.7. Some of you use Python 3.8. I don't really care. So it's always the same order as of now. But we are just trying to warn you, not now, not in the course. In the course, it's okay. If you are doing some Python work later yourself, then you have to make sure that you understand this property. So let's say you write a program and then you read a dictionary and then you assume that the order is the same, but you throw the program to another guy's computer, the other guy's computer is using Python 3.4, then the order is not guaranteed. So then your program is going to work like trash. Okay, so that means cannot be for granted, but this is not for the course, this is just for your future work. Okay, so standing out thing, finally, the final thing that we want to talk about here, you cannot use a list as a key. Oh well, so what's the point here? The thing is, we talk about lists and tuples and strings and all the other stuff, and then when we talk about lists and tuples, we said that, oh, lists are so powerful, so probably in the course you don't have to use tuples. So every time if you have a choice, you will do lists. So what is the other time that I cannot use lists? So this is the other time. So if you want to put some items, multiple items, as a key, like this, list does not work. So you cannot put a list as a key. So what can I do? You can only put a tuple as the key. So you compare these two, the things are exactly the same. So it's just simple numbers collection. It's just that this is a list, this is a tuple. Oh well, oh my god, why? So why is this a strange rule so that you can only use a tuple as a key in the dictionary? I cannot use a list. So for that, we do not really want to explore too much, but that is related to the way that you can use a list. So you can change a list anytime you want. So that is a problem for a dictionary key. So you cannot change a tuple, so dictionary very happy. So you can use a dictionary in a dictionary, cannot use a list over there. So you have to remember that. So you have to like put it in your head, and so don't ask why. So well, there is a why, but you just kind of remember this now. So don't put this in the key of a dictionary. Okay, so that's what it is. And any other? No, finish. Okay, so dictionary, great. So what's the use of this? What's the point? Well, it's useful because you don't need to remember the number. You just need to have a mapping, which proves to be very useful in some of the cases, like what? Like Lab 7. So Lab 7 will use a big dictionary. So we will try to explain that dictionary next time. Okay, now more importantly is to understand these timers, using timers. And you look at that, and it turns out that this is very simple if you understand the examples. So, problem with insert time is just skip it, so forget about it. So the main thing is this. The main thing is you already know how to work with timing. Look at this program. What do you expect? I run an infinite while loop. So that means I'm going to run this loop forever. Okay, no problem. Run this forever. So I'm going to show you a number and add it by 1. So start with 0. So I print you 0, add 1. Next time, print 1, add 1. Next time, print 2, add 2. Next time, print 3, add 3, and then just keep on repeating. So if you let's pretend that you don't see this, then if you run this program, you will have 0, 1, 2, 3 coming up very quickly because it's a simple loop. Keep on printing, keep on printing. Now you already know how to use time dot sleep because you have kind of looked at that in the midterm. Oh yeah, time dot sleep meaning that I am going to hold the program for this amount of time. So the meaning is, I am running this program, going into the loop. I stop here for exactly 1 second. So I stop here for exactly 1 second, come back, run this, and then stop exactly at this point 1 second. Come back, run this. What this code is going to give you is a counter. So it becomes a counter. I show 0 at the start. 1 second later, I show 1. 1 second later, I show 2 and 3 and 4. It's a counter. So if you run it, then it's not perfect. So look at that, and then you try to run it. The example is over here. Which video I have already opened it. So anyway, so let's use this one. So if you run it, very simple. Go on, run, and it is going to give you a shell which is going to count the time and just go on kind of forever. So it's kind of boring to do this, so let's just let it just run like that. So every 1 second give you a number, every 1 second give you a number, and that's the way it is. Well, no problem. But there is a problem, actually. The problem is, this is the way that you write a program so far. So far means that before lab 6, this is the way that you write a program, and that is the way that you run a program. What does it mean? The way is you start from the top to the bottom and keep on running, and then you just stop at a point, waiting, do the next line, come back, stop here, do that, go to the next line, do that, go to the next line. So there is no other way that you can run any other stuff. So you don't care actually. So you run this program, you are stopping here for the entire 1 second doing nothing. And then come back and run this and stop here doing 1 second of this without doing anything else, and then come back. Okay, it's not a problem, but we are saying that it will be much better, much better. You are waiting anyway, so you're waiting for 1 second. It will be much better if you can just say, I am waiting, but while I'm waiting, I want to do something else. Alright? So I really want to do that because you're wasting my time. So I'm counting this, so no problem, you count this, but I want to do something else while I'm counting. So can I do this here? No, because this time dot sleep is really occupying the program, stopping you from doing anything. So this is not the way to go to do it. And what's the way to do it? And the way to do it is obviously the thing we're talking about. So the thing that we're talking about is this guy. Turtle dot on timer. Oh my god, so I have learned turtle dot on click and turtle dot on drag just now. So you're adding another one. So turtle dot on timer. So it's easier to understand turtle dot on click means that you click on the turtle, it's an event. So turtle dot on timer means that I am doing a timer on turtle. But this is not exactly the same thing that you have used before. This on timer is really talking about the timing. So if you look at this, very simple. Give me a function, give me a time. I am going to do this function after this time. Okay, so that's it. So you can try and do this in your program. So rather than using this, let's get rid of this, save trouble. So let me go to this. Oh, well, where is my guy? So my guy is not this guy, not this guy, not this guy, not this guy. So my guy is this. So by the way, somehow I try to find the turtle game that I have made in the last lecture, but I cannot find it. So somehow somebody stole my file. Okay, probably I accidentally deleted it, but I have this one here, which is more or less the same. So this is the turtle game thing. You remember, turtle game thing, run this, and then, all the turtle come up, and then you just pick the turtle correctly, and you win the game. Well, that's the game. Okay, hopefully you remember that. What I'm going to do is, I am not going to give you that much time. So I'm going to change the program a bit, so that I'm going to give you only 5 seconds to do it. If you cannot do it, I'm going to show you the result, so you cannot play. So very simple. I am asking the program to give you 5 seconds to do it. If not, then I'm going to show you the answer. So I am going to do this, use my turtle to set a timer, and then run a function. Let's say the function is game over, so you have enough time. So 5 seconds. So 5,000 means 5 seconds. And probably say 5,000 is 5,000 seconds. No, this is 5 seconds. And then here, game over is the function. And notice that I don't need to use XY this time. I need to use XY that time. On click XY, on drag XY. This one, no XY, because I am not dealing with the mouse. No XY. Okay, no XY. And then I am giving you the answer. So no game. So here, view color, let's say is yellow. Done. So what I'm doing is, I am giving a function. 5 seconds later, please run the function. That's about it. So this is the instruction. 5 seconds later, please run the function. So you run it, and then show the turtle. Okay, so it's like 3, 4. Yeah, so this is the answer, and then we're only at 5 seconds, but you can see like, this is the answer, right? Oh yeah, so like that. But you know, oh well, this is the answer, and then it's game over. Okay, so you have a timing that you can control in the game, but notice one thing. If I use this approach, even if I'm waiting like this, I run it again, even if I'm waiting, so it starts when I finish. So, even if I'm waiting, I can still do it. I can still click. So I can still click the one, this which is the real turtle. So I can still try to play the game while I'm waiting. If you use time.sleep, no way. Time.sleep 5, then you are holding up the program and then you cannot do anything. Alright? So that's why we are trying to say that this on timer is actually a little bit better than using time.sleep. That's it. And then you know, say anything? No, that's it. So looking at this, so it's pretty simple then. That is just meaning that you can try to assign some work to do after a certain time. Here, assign this work to do after a certain time. Okay, so run this function 2 seconds later. So you run the program, nothing is shown. 2 seconds later, there is a circle. Okay, and so is there any other things that we have to learn here? No, that's it. But then, you have to be careful when you use this kind of program. So let me just quickly show you. Come back here and then look at this example. Not this one. I want to look at this little countdown timer guy. So countdown timer guy over here. This is the one which is using time.sleep to waste your time. Okay. So can we change this to another version so that you don't waste your time? Well, in some sense. Well, that means I want to change this from time.sleep to turtle.onTimer. How can I do that? So very simple, I just have to import my turtle. Okay, so for start, I need to import turtle. And then I would not want to do this time.sleep, so I delete it. So if you do this and then you run it, you will know that it doesn't really work like that because you are going to print the whole thing forever. So how can I make it so that it becomes something that I can have the timing? So you need to use your on timer first. So let's say turtle.on timer, and then you have to give it a function. Oh my god, what is a function? There is no function. Make it. Okay, so this is the thing, these 2 lines is the thing that you want to do with timing. Alright? So it's pretty obvious that these 2 lines should be the thing that you put into the function that you give on timer. So I will change the loop content into a function rather than the actual infinite loop. You understand what I'm saying? Because these 2 are the things that I want to have some timing. So rather than an infinite loop, I really should try and change this into a function. Let's call it counter. Alright? If you do this, probably you will know that you need to get this global in. Otherwise, you cannot change the global variable because this side is the global variable. You're now creating a function. So if you want to change the global variable, you have to do this. Okay, now, done, finished. So there is a counter. And then you do this. Oh yeah, let's run counter 1 second later. So 1 second later. And look at that. Oh, you set it? Yes, you set it. Finished. So run. Oh, where is the time? The time is not in the window, by the way. The window is kind of empty. So the time is here, 0. Okay, so you are doing this so that you are running this particular function. If you ask me to do it 1 second later, so I show it. Where is second number 1? Where is second number 2? Well, we don't have this working in the program. You are asking me to do it once, I do it once, and then finish. Okay, so how can I do it again? So the point is, I am asking you to do counter. So you go into counter and do this. After you do this, please do it again. So that is what you should do. So please do it again. So how can I ask the counter to do it again? So the way that you do it is very simple. You just go up here and then say, hey, after you finish, please do yourself again. Counter. 1 second later. Okay, you look at this program, where is it here? Well, you are duplicating the code. Oh yeah, I'm duplicating the code. This code is to start the counter 1 second after I start the program. This line is trying to run counter 1 second after I run this. So 1 second after I run this is not the same as 1 second after I start the program. So I am starting the program here, and then 1 second later I run this. So I am already 1 second after I start the program. After I print the number to you, I am telling you to do it again 1 further second later. So after 2 seconds you start your program, you run this to print your 1. And then I am asking you to do yourself again 1 further second later. So 3 seconds after you start the program, you print me a 2, and so on and so forth. Okay, so if you do this, that means you will be able to run this and 0, 1, 2, 3, 4. Don't look at the window. So it's here. So 0, 1, 2, 3, 4, 5, 6, like that. You will just try to count the time, just like that. Without any problem. Close. And to be super careful, you should really put the turtle dog down at the end, because that is the proper way to run the program, so you should really do it. So that will complete the conversion of the original program into the turtle dog on timer version. So if you look at this one create a loop for you. This one become a loop. So you are starting the loop, and then you run the function, and then you do it again. So this one becoming a loop. So that is kind of important, because you look at the code, you don't get the sense that this is a loop, but this is a loop. So this is a loop running around with some timing, and that is important. Oh, by the way, actually this program is not the same as the previous one. The previous one we will print the number 0 immediately we start the program. This one is not. This one is going to run the counter 1 second later. So it is not exactly the same as the previous version. So if you want to make them the same, you should really do this rather than using a timer. You can just start the counter, then you will have 0 at the start, run 0, 1, 2, so 2, 3, 4, like that. That will more or less the same kind of thing that you will see in the previous example. Okay, now finish. You say another thing. Basically, this is just kind of the same. Creating a time interval, this is just the same thing, it's just the function is a little bit different. And then this is just again something that you have to remember. Don't put parentheses when you use on whatever, on click, on drag, on timer. Don't try to put parentheses, doesn't work. So it is the name of the function. And so this is another example. I'm not going to talk about this, it's a super simple. You should read what is the point about this. Okay, so now we have a few minutes, so let's just try to do this. Go up here, and so you know that this is a counter. So a counter, so it will count forever. So let me try to do this in my game, so that my game has a better countdown system. So where is my game? My game is here. So my game works like this. I am telling the game that I can click on the turtle. If it is red, if you click it correctly, then it becomes red. But I give you only 5 seconds to work on that, right? But you don't know the timing. You will never tell me what's the timing. So, how can I actually play the game if you don't have timing? So let's try to add a timing to the program. How? Well, you can just copy and paste this. Very easy. So I can just copy and paste this counter. Copy and paste this over here. So I'm not going to use this CD timer anymore. So copy and paste this. Okay, so I have a counter, but well, so I get the seconds equal to 0, but rather than having the seconds equal to 0, I should start from 5. I'm doing a countdown. So originally over there it's counting up. Okay, so it's counting up. I'm trying to do a countdown. So I start from 5, and then every time I count, I am going to subtract with 1. And rather than printing this out, let me just try to do it in the proper way. So T equals to turtle dog, turtle, so I'm creating a turtle, T dog, hi turtle, and then let's use this T guy to print out the second. So that means I can have light clear, and then write the string version of seconds. You cannot put the seconds there, you have to do a string version, remember? So that will be my big kind of time that you will be able to show somewhere. Okay, so let's do this. And then try to run it.
You're missing a
Close. Okay, run, done. And then go up, and then wait for it to come up. 5, 4, 3, 2, 1, 0. Hooray! There's one. Okay, so that's a problem. Oh, what's the problem? Well, in our example, we just keep on counting up. 0, 1, 2, 3, never stop. So here, I'm going to count down, and then 0, 5, 4, 0, never stop. So never stop, so that's why it goes down to -1 and go on, forever. Why? Because we have a loop here. This is kind of an infinite loop. It never stops. Because you run, you go back. You run, you go back. How can you stop? Well, look at this. If I do this, it will go on and do it. If I don't do this, it stops. So if you try to mimic the kind of loop idea, you can do this. Come off here. Let's do it in the function so that I don't do your on timer every single time. So if my second is equal to 0, then not equal to 0, is bigger than 0. If it is bigger than 0, I am going to do it. What's the point? Certainly, if I am 0, I don't want to do it. So that's the meaning. If I am 0, I don't want to do it anymore because I already have enough time. So you can just do it like this and put an else here, meaning that when I don't have any time left, so actually it should be bigger than or equal to 0 because that seconds is actually a little bit smaller. Anyway, so total let's do this. Total dog color is yellow, something like that. All right, run, do this, and then come, and then 5, 4, 3, 2, 1. Come on, faster. 0. Oh yeah. So that's finished. Okay. So you stop it when the time is 0. It should be bigger than equal to 0 for this because we subtract the number after we show the time, so it's bigger than or equal to 0. So that means you stop it when you may get into the negative side. So you will want to stop it at that time. Okay. Other than that. That is the way that you have a timed loop. So this is a timed loop. So if you use a simple loop, while loop for loop, you want to create a timed loop, you have to use time.sig. Can you do anything else? Here, I am doing a timed loop, but then this works inside the kind of timer event. And then I can do whatever else that I want to do at the same time. Okay? So, fine. Now, that's it for this and for today. And next time, we are going to do this. We are going to look at this screen event, which is super simple. We are going to quickly look at this summary, which is useful maybe later, but for now, it's just one page. It's very useful. And then for the rest of the time, we will look at the Lab 7, showing you what exactly is the things that you want to try to do in that lab, which is actually very long. And then we expect that you have to prepare for the lab before you actually go to the lab next week. So don't just hop into the labs thinking that you can finish the whole thing without actually doing any preparation. Okay, so that's for this lecture. So see you next time.